At first glance, this looks like the sort of trigonometry problem that will be easy, right? And 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 put some information in there about the side lengths, and la-di-da, we're all done. Okay, that would be really nice. But look at what I drew, and look at this piece of information over here, and see if that makes any sense. Can you have a right angle triangle that has another angle in it that's like 170 degrees? That makes no sense at all. So this is a sort of problem that you might run into during a junior year trigonometry class. It's a little more complicated version of right triangle trigonometry. You've got an angle that's more like this. Okay, here's my theta. It's somewhere between between 90 and 180 degrees. Now that makes a triangle over here, and we can still do right triangle trig on it, but we have to use this little trick where we imagine the angle being over here, and that's called a reference angle. In other words, it's not exactly the angle that we're talking about. I mean, clearly you can see it. The angle that I just drew inside the triangle is not 150 degrees, but it's going to stand in place for the 150 degree angle. And I won't go into all the reasons of why this works, but it does. It's one of those cute things about trigonometry. And now I just want to remind you of SOHCAHTOA, which we can still use in this image, even though there's some silly stuff going on with that triangle. SOHCAHTOA says sine of theta equals opposite over hypotenuse. And cosine of theta, well, that equals adjacent over hypotenuse. Now, if cosine, and now we got to switch which piece of information we're using here. If cosine equals -5 over 13, and that is my adjacent over hypotenuse, that tells me that hypotenuse is 13, and adjacent right here is -5. And if you're perceptive, you might be wondering why I didn't label 13 with the negative sign and 5 with the positive sign. Here's a rule. Your hypotenuse always has to be positive. Always, always. Otherwise, you get some very, very silly things, and the trigonometry is going to break. So your -5 going left, that kind of makes sense because that's off to the left of the graph, right? That's negative x values. And your 13 is positive. Now, what is this right here, which I'm going to call, I don't know, my B's look like 6's, so let's call this an A. Right? What is A in that triangle? If we use the Pythagorean theorem, we get a squared plus that side, which is -5 squared, equals the hypotenuse squared also, which means a squared plus 25 equals 169, which means a squared equals 144, which means a equals plus or minus 12. You have to pick the plus or minus based on what makes sense in the picture. Well, which one makes sense in the picture? I hope you're saying positive 12 makes sense because it's going up, right? That's up, not down. So we're going to put a 12 here, and I'm going to say this algebra we don't need anymore. Okay, scroll back in the video if you want to look that over again. And now I want to know, what is sine of theta? We're just about done. Well, the opposite is always the side furthest away from your angle, even the reference angle. So that's going to be 12, and hypotenuse is 13. So that is our answer.